A thin sun burned through the Sahara dust as 5 Sherman tanks eased over a ridge in February 1943. Engines rattled, crews swept the horizon for shapes. From the German positions below, it would have looked like a scattered line of targets, pieces of metal prowling the sand. What the German tank commanders could not hear and what they did not suspect was a steady human voice threading those tanks together. Short, calm orders, position reports, requests for fire. The Americans were talking to one another as if they were standing on the same ridge, although sight lines were broken by dunes and heat shimmer. The Germans heard only static. That moment, commanders acting in unison that should have been impossible from their perspective, answers the question at the heart of this video. What German troops didn't know about the power of American Sherman tank radios? This is not a claim that radios won every fight or that steel and gunnery were irrelevant. It is a narrower, more precise story. By equipping nearly every Sherman with a reliable, crystal-controlled FM radio system and training crews to use it, the U.S. created a battlefield advantage that altered decision tempo, unit cohesion, and the ability to exploit fleeting opportunities. That invisible advantage often converted local superiority into decisive action before German commanders could react. Over the next half hour, we'll follow that human voice from the dunes of North Africa to the bocage of Normandy, through Italian ravines and across rivers discovered by pontoon bridges, showing how a set of radios and the factories that made them became tactical force multipliers. If you like deep dives on WW2 tech and tactics, subscribe and stick around. There's a lot to unpack. Technical reveal: what was in that voice and why it mattered. At the core of the Sherman's communications advantage was the family of radio sets associated with the SCR 508 series. On a Sherman, you typically find a B604 transmitter, B603 receivers, and a B606 intercom for the crew. In plain terms, the B604 sent the signal out. The B603 received signals. The B606 let the crew inside the tank speak to and hear each other clearly. FM, frequency modulation, was the key choice. Plainly put, FM encodes information by changing the frequency of the carrier wave, whereas AM, amplitude modulation, changes the signal's amplitude. The practical consequence: FM is much more resistant to background electrical noise and engine or ignition interference. Where AM transmissions warp or fade amid static, FM keeps the voice intelligible. Plain English, FM makes speech cut through the engine roar and sprayed dust. AM tends to drown out or distort that speech. Another crucial feature was crystal control. That meant the transmitter and receivers were locked to precise frequencies using quartz crystals, analogous to tuning an instrument to a fixed pitch. Crystal control prevented drift and made it easier for multiple tanks to operate on the same channel without unintended crosstalk or frequency wandering. The BC604's reported output, around 25 watts, figures per source, verify, gave effective tactical range in the field considerably greater than many contemporary German sets that often ran at lower power. In practical terms, higher wattage and FM clarity allowed conversations and short, clear orders across greater distances, even while tanks were moving or under fire. Inside the tank, the intercom mattered almost as much as the external radio. The BC606 and similar sets allowed the commander, gunner, loader, and driver to hear one another and to monitor the external radio simultaneously. In plain English, the intercom made the Sherman's crew a cooperative team, able to combine local internal awareness with the wider picture provided by radio nets. Equipping whole units with transmitters and making them part of a net, rather than giving a single command tank a transmitter while subordinate tanks only had receivers or none at all, was doctrinal and industrial. The U.S. invested both in the hardware and in the habit of talking. That combination was the important, often overlooked point. The technological capability mattered, but only if doctrine and production made it an army-wide practice. The Galvin Motorola story and the industrial backbone. The radios that filled Shermans did not spring from a single solitary genius in a lab. They were the product of wartime engineering teams, corporate retooling, and the American industrial machine. Companies like Galvin Manufacturing, known today as Motorola, adapted and mass-produced radio designs suited for armored vehicles. Engineers had to solve real problems: vibration that could crack components, temperature extremes inside cramped steel boxes, electrical noise from engines and ignition systems, and the need for ruggedized connectors and headsets that crews could use in combat. Daniel E. Noble figures in many accounts as a principal RF engineer at Galvin/Motorola during this era. Role as stated in source, verify. Teams also drew on the work of Edwin Armstrong, the inventor who had made FM practical on a larger scale. Making FM work inside a tank was not a trivial transfer from civilian radio. Components had to be shock-mounted, power supply stabilized, and the sets configured for crystal channels used by the Army. Each complete set included dozens of parts: transmitters, receivers, cables, headsets, intercom units, and mounting hardware. And those parts had to be produced, shipped, and installed in thousands of tanks. The industrial achievement was not only the adaptation of FM to armor, but the scale. Within months and years, the U.S. was producing radio sets fast enough to outfit the bulk of its Sherman fleet, tens of thousands of tanks. Production totals per source, verify. This near-universal installation mattered because a radio is most powerful when others listen and speak. A tech advantage that sits inside a small number of vehicles is limited. A tech advantage woven across divisions changes doctrine and tactics. Kasserine Pass, the first real shock. When historians point to a single dramatic early example, they often return to the North African fighting around Kasserine Pass in February 1943. Here, the U.S. Army, still learning hard lessons, faced seasoned German formations. On paper, many American units were raw. In practice, American units that coordinated well could accomplish surprising things. Picture that earlier scene again: a Sherman troop conducting a bounding maneuver across dunes in a haze. One tank screens left, another delays on high ground. The rest fall into a moving diamond. To a German platoon commander watching through a periscope, the American formation looks splintered. But when an American commander calls for concentrated fire, an artillery correction, or a withdrawal, the response comes fast. Guns pivot, smoke goes down exactly where ordered, and units line up trajectories within minutes. What German crews heard, static, told them only that American tanks had no cohesion. What they didn't know was the mechanism producing that cohesion: a network of crystal-controlled FM radios with trained crews accustomed to communicating. Why did that surprise work? Consider two effects. First, real-time situational sharing allowed commanders to coordinate fires and maneuvers without needing to see their targets or their subordinates. Second, redundancy mattered. If one tank's commander was knocked out, another could assume command on the net. Contrast that with a formation in which only the lead tank has a transmitter. Lose the lead, and a whole wing goes silent. The German reliance on visual signals and rigid command hierarchies exacerbated this vulnerability. When radio-equipped command tanks were lost, cohesion often evaporated. Italy, FM in complex terrain. If the North African plains tested tanks' long-range communications, Italy tested them in a different way: terrain. Mountains, ravines, and dense olive groves create multipath propagation and signal shadowing, radio behavior that can be chaotic. In these environments, FM's resistance to noise and its clearer voice made an operational difference compared with AM systems. At Cassino, verify proper reference Monte Cassino/Cassino, and other hill fights, American armored units maneuvered in terrain that interrupted line of sight. A Sherman that could talk through the static and conferring voices with neighboring tanks could coordinate short thrusts into defiles, call for smoke or close artillery support, and interface with engineers building bridges or clearing mines. German forces, often using AM sets with less immunity to engine and electrical noise, found their nets less reliable when the environment turned complex. The result was not inevitable American victory, but a persistent tactical edge in maintaining cohesion and reacting to changes. Normandy and the bocage, radios and the hedgerow problem. Landing in Normandy in June 1944, American forces confronted a landscape of dense hedgerows and narrow lanes that stymied movement and observation. Early on, Sherman crews discovered that radios allowed small units to synchronize approaches and to call for immediate support from mobile artillery and tanks that otherwise would have been out of sight. The hedgerows created a tactical problem. Infantry and armor had to clear blind corners, and supporting tanks could not always see where their colleagues were firing. By using the radio nets, commanders could give precise relative directions. Right flank, 3 o'clock, 50 yards. Smoke left of that, then overrun. Even when line of sight vanished, voice filled the gap. That real-time coordination reduced delays and casualties that otherwise accumulated when units relied on runners or prearranged signals. A practical improvisation worth noting. Early incompatibilities between tank radios and infantry communications led to field workarounds, such as wire phones routed to a tank's interior or infantry runners guiding a tank by mast-mounted flags. These improvisations highlight an important lesson. Radios did not solve every problem instantly, but where they existed and were used, they accelerated learning and adaptation. Operation Cobra, scaling the network. If Kasserine illustrates tactical surprise, Operation Cobra, the breakout from the Normandy lodgment in July 1944, shows what happens when the network effect scales. Cobra was not merely a concentrated use of armored power. It was a coordinated surge of hundreds of Sherman-level nodes operating on shared frequencies, with aircraft, artillery, and infantry linked into the plan. When hundreds of tanks and supporting elements operate in a synchronized fashion, the sum is greater than the parts. Timely transmission of where a gap had opened or where German counterattacks were forming allowed U.S. commanders to pour forces into a rupture before German reserves could respond. This forced rapid decisions at lower echelon levels. The German command structure, which at times depended on slower information flows and physically co-located command posts, was forced to react to emergent situations the U.S. created faster than they could reorient. Remajan and late-war exploitation, information overtakes movement. Across late 1944 and into 1945, the strategic value of fast information became clearer. The capture of the Ludendorff Bridge at Remajan, generally accepted, verify spellings dates if needed, and the subsequent establishment of a bridgehead is often taught as an operational opportunity exploited by speed and aggression. But the ability of armored spearheads to press across newly opened gaps depended on communications that could propagate orders and reports quickly. A Sherman commander reporting a shallow crossing or the presence of an enemy rearguard could cause follow-on units to divert, concentrate, or consolidate in minutes. That speed of information flow frequently outpaced German decision cycles. Where German forces had to marshal reserves, move them through choke points, and update layered command posts, an American formation wired into an FM net could redistribute combat power far faster. The net did not replace brute force, rather it allowed force to be applied with decisional advantage. Contrast, German AM systems and doctrinal choices. To explain what German troops didn't know, it's necessary to compare the American FM approach with German practice. German armored radios, the Fug series, e.g. Fug 5, use specific model confirmations, verify, were often AM-based in early and mid-war versions, ran at lower transmitter power in some models, and, critically, were not uniformly distributed as transmitters across every vehicle. In many German formations, doctrinal emphasis favored centralized control with voice of command transmitted from a small number of command tanks. Subordinate tanks might only have receivers or no radios at all. That organizational choice reflected pre-war doctrines that valued visual cohesion and command concentration. AM's vulnerability to electrical noise, especially in tanks with older ignition systems and complex engine environments, reduced effective clarity under combat conditions. So even when German radios were present, their performance often degraded as engines thumped, shells burst nearby, and the battlefield became electrically loud. Where a Sherman's FM voice remained intelligible, an AM net could turn into a chorus of static and fragmented words. Additionally, production and supply constraints mattered. U.S. industrial policy, both the will to produce radios at scale and the logistical means to install and support them, created near-universal deployment. Germany, which faced Allied bombing, resource scarcity, and competing production priorities, could and did field capable radios, but often not at the same breadth or with the same doctrine of universal transmitter deployment. The result was an asymmetry. When U.S. doctrine expected open nets and decentralized command, the hardware existed to support it. When German doctrine relied on fewer transmitting nodes, losing or jamming those nodes had outsized effects. Limits and caveats: not every victory, not every failure. This emphasis on radio should not be read deterministically. A reliable radio net did not automatically equal battlefield mastery. The Shermans themselves had limitations. Armor and firepower contested by German Panthers and Tigers in certain contexts. And other factors like training, logistics, air support, and local terrain often decided outcomes. There were battles where German crews, superbly led or fighting defensively in prepared positions, held off larger U.S. forces despite American communications. The claim here is subtler. Radio networks changed the set of possible actions and raised the value of timely decision-making. When combined with numerical superiority, air power, and logistics, communications helped convert advantages into operational success more often than not. Examples of German countermeasures existed, but they were not universal panaceas. Electronic jamming in WWI was primitive compared with later eras, and the Germans generally lacked an organized, large-scale doctrine of EM suppression that could fully nullify U.S. FM nets across a theater. Meanwhile, losses of key command nodes could still create confusion for American units. The network reduced that risk through redundancy, but did not eliminate it altogether. Human dimension: crews, voices, and the psychology of connectedness. Technology is only as effective as the humans who use it. For Sherman crews, the radio was more than gear. It was a psychological tether. Crews who could hear friendly voices while exposed to incoming fire felt less isolated. They could coordinate immediate, life-saving maneuvers and call for medical or logistical support. The intercom inside the tank allowed the commander to keep situational awareness while giving orders and listening to the net without shouting over the engine. From the German perspective, the pervasive presence of radio chatter could be disorienting. A commander watching a skirmish might be unsure whether he faced a local concentration or the tip of a larger coordinated thrust. That uncertainty prolonged decisions and often caused conservative choices: delay, withdrawal, or fragmented counterattacks. In war, information reduces hesitation, and hesitation can be lethal. Operational details: how radios were used tactically. On a tactical level, several recurring radio-led behaviors appear across campaigns. Immediate fire control: a tank caller would request a barrage or call for neighboring tanks to focus fire on a target. Those calls shortened the time from target detection to engagement. Maneuver coordination: bounding movements and envelopments required synchronized timing. Radios allowed precise calls like "push on my position at 1200" that runners or flags could not deliver reliably. Redundancy of command: if a platoon leader was hit, the net allowed another leader to assume command quickly. Crews trained to listen on specific frequencies made such transition smoother. Integration with supporting arms. Radios linked armor to artillery and air liaison, enabling faster requests for close support and more accurate corrections on the fly. Each practice required training. Crew drills on how to report targets, how to use brevity codes, and how to keep nets clear of unnecessary chatter. The U.S. emphasis on training for radio use therefore amplified the hardware advantage. Manufacturing detail and how many with verification flags. When we discuss numbers, how many radios, how many Shermans equipped, the broad claim stands. American production and installation were extensive, often near universal for frontline Sherman units. Precise production figures and counts of sets per vehicle should be verified against primary sources. Production totals per source, verify. The most defensible way to present the claim is to emphasize scale and ubiquity rather than an exact tally, enough to make radio communication standard practice at the company and battalion levels in armored formations. Legacy, the roots of network-centric thought. If there is a through line from the SCR 508 family to modern doctrine, it is conceptual. When individual platforms can share timely information and commanders grant latitude to subordinate units to act on that information, decision cycles shorten. The Sherman's radio net was a primitive ancestor of later network-centric systems, not in the sophistication of technology, but in the doctrinal insight that connectivity multiplies combat power. Later conflicts, from the communications-heavy tactics in Korea and Vietnam to the sensor-fused, data-linked operations in the Gulf Wars, illustrate further evolution. But at the tactical level in WW2, the U.S. practice of equipping armored formations with reliable FM sets and training crews to use them was a formative case of connectivity shaping tactical outcomes. What German troops didn't know in practical terms. Summarizing the thesis in operational language. German troops often lacked a mental model of American forces as a web of small, connected decision-makers. From a German command vantage, separate American tanks could look isolated and thus manageable. What they didn't know or failed to appreciate was that those tanks frequently operated as parts of an alive network, sharing eyes and voices across terrain, able to concentrate fire, shift, and exploit gaps in minutes rather than hours. The combination of FM clarity, crystal stability, effective intercoms, and mass installation turned individual Shermans into nodes of a fighting system whose tempo and cohesion surprised many opponents. Editorial and verification notes. Certain names, spellings, and numerical claims need confirmation before publication. Examples flagged for verification. Precise production totals for the SCR 508 family and Sherman radios, production figures per source, verify. The exact wattage values and frequency ranges for BC 604 by BC 603 components, specs per source, verify. Identification of particular engineers with specific titles, e.g. Daniel E. Noble, role per sources, verify. Model references for German Fugue sets when cited by number, e.g. Fugue 5, verify. Historical place names sometimes appear with variant spellings in older transcripts. Confirm references such as Kasserine Pass, Monte Cassino, Indefined, verify. Remagen, and the names of German formations like Panzerlehr, indefined. Verify any garbled unit names found in lower quality transcripts. Strategic synthesis and final reflection. In war, the visible meets the invisible. Steel, speed, and shell fragments are obvious. Electromagnetic waves are not. But those waves carried decisions, coordination, and presence. The American choice to equip Shermans with robust, crystal-controlled FM radios, to train crews to use them, and to mass-produce the hardware created an operational advantage that German troops did not always perceive in the heat of battle. It was not the only reason Allied forces prevailed, but it was one of the structural, repeatable factors that multiplied other strengths. 2 closing points for context. First, technology requires doctrine and production to matter at scale. A superior device in a handful of tanks is a limited gift. The Sherman's radios mattered because they were widespread and integrated into how units fought. Second, the story is a reminder that warfare evolves not only by bigger guns, but by better connections. The Sherman's radio networks were an early, practical lesson on the tactical value of information, a lesson that echoes in how modern militaries organize sensors, shooters, and decision-makers today. What German troops didn't know was that the Americans had, in effect, turned each Sherman into a tiny command post on a communal network. To the German field commander watching through a slit, the Shermans could look like individual threats. To the American division commander hearing steady, coordinated reports, those same tanks were a single, malleable instrument of movement and fire. That invisible link, the voice across the ether, made all the difference in many pivotal moments. If this exploration raised questions, check the source notes linked in the description for deeper technical references and campaign histories. And if you want more on the Sherman's development, the engineering behind the radios, or a closer look at a specific battle, Kasserine, Casino, Normandy, Cobra, or Remagen, subscribe and suggest which episode you'd like next.